All right, section 7.4, part 2, complex, or what we call nested fractions. Okay, so this is on the back of your 7.4 notes. Okay, so you've already taken this skill check. So we already know how to add and subtract rational expressions. You've already taken the skill check on that. So now we need to learn how to simplify what we call these complex or nested fractions. So first of all, what is a complex or nested fraction? Basically, it's a fraction within a fraction. So, for example, if I had a fraction bar here, and I'm taking 1/3 and adding 5, and then I want to divide that by 6 plus 2/5. So here I have a fraction within a fraction. So I have to think about this as really this fraction bar here is a grouping symbol. It's separating my entire numerator from my entire denominator. So we call this a complex fraction because it has a fraction within a fraction. Again, this doesn't mean, a lot of times when we think of complex numbers, we think imaginary. This doesn't mean imaginary. That's why a lot of textbooks and stuff call them nested fractions. It's a fraction sitting inside of a fraction. So really, it's a fraction in a fraction. Okay? And we don't like them. We want to simplify them to just be one single fraction or one single number. So in simplifying a complex or nested fraction, there's really two methods. There's one method I like to call clearing the fractions, and there's another called rewriting as, you just rewrite it as a division. Okay? So first of all, in clearing the fractions, okay, so I'm going to do two different methods, so I'm going to kind of color code here. Here, let's go ahead and clearing the fractions. Let's do this here in purple. So here's my original problem. We've got 2 over x minus 4, and I'm writing my 4 because that is a 4 in the numerator. Okay, all over 2 over x plus 3. So this is entire numerator right here. This is entire denominator. So what I'm going to do is I'm going to put parentheses around these two pieces. So we know we have this piece divided by or over this piece. So now I look to see and find a common denominator between all of my small fractions inside of here. So I'm going to find a common denominator between, this is 2 over x. This one is just 4 over 1. This is 2 over x, and this is 3 over 1. So if we look at our denominators here, we've got x, 1, x, and 1. So my common denominator here would be x. So then what I'm going to do is I'm going to multiply the big numerator times x and this big denominator times x. So how I got to this is I got a common denominator. So now I'm going to take this x and I'm going to distribute it into here. So I'm going to take this x, I'm going to distribute it in, so we're going to multiply it times both of these. Okay. So I would have 2 over x times x minus 4 times x all over, and I would do the same thing here. We'd have 2 over x times x plus 3 times x. So I just distributed this x into both of these as well. Hey, but then if I take 2 over x times x, this is x over 1, my x's divided x cancel, and I'm just left with 2. And then minus the 4x. So I no longer have a fraction in my numerator. All over, and now do the same thing here. This x divided by x is 1, so I'm left with 2 plus 3x. Okay. So now I no longer have a fraction within a fraction. So now we look to see, can this be simplified? Okay. So can I simplify this somehow? I could factor a 2 out of this numerator, and I'll be left with 1 minus 2x. All over. But I can't factor anything out of that denominator, so nothing will cancel. So I think this is about as simplified as it will get. Okay. All right, so that's one method. Okay, it's called clearing the fractions. Okay, another method is called rewriting it as a division. So when we're rewriting it as a division, what we're going to think of is, here's our original problem. We're going to think of it as this piece divided by this piece. So that's the first thing I'm going to do, is I'm going to write it as division. We have 2 over x minus 4, this whole piece, divided by, I'm going to put the divide sign in here instead, 2 over x plus 3. Okay. So now, to do this division, I need to work inside parentheses first. So I'm going to need to subtract these two. To do that, I'm going to need to get a common denominator, so that's over 1. So my common denominator would be x. I don't have to multiply x by anything to get to x, so I just bring the 2 down. But this one, I'll have to take the 1 times the x. To get to the x, I have to take 4 times x. So it would be minus 4x over x. So I have that guy, and I'm dividing it by, and then I repeat the process over here. Okay, that's over 1, so my common denominator is x, the plus in between. This, I don't need to multiply by anything to get to the x. This one, I have to take the 1 times the x, I have to take the 3 times the x. So now I've got common denominator, so now I can put them together. So I have 2 minus 4x all over x, this guy, divided by 2 plus 3x all over x, divided by that guy. Well, so now I have one single fraction divided by one single fraction. So we know dividing by fractions is the same as multiplying by the reciprocal. Previous section, this is the same as multiplying by x over 2 plus 3x. So now we'd multiply straight across. I'm actually not going to distribute that in. So I'll have x times that, so this will give me x times 2 minus 4x all over x times 2 plus 3x. But now these x's are factors, so x divided by x is 1. So we're just left with 2 minus 4x all over 2 plus 3x. And that's as simplified as it goes. If you notice, we got the same answer here in purple, here in blue. Okay. So there really is no difference there. Okay. It really just depends on how you see it and what you feel would be easiest. I prefer clearing the fractions. This is the method I prefer. Okay. If you want to rewrite it as division, that's fine. This to me involves a lot more work. You have to get the same common denominator twice, which I don't enjoy. This, so I don't really like this one as well, but you are free to use it. Go ahead. Hey, I'm going to do 2 more examples. Okay, I'm going to do both of these by clearing the fractions. Okay, so here is my numerator. I have x over 6 minus x over 3 divided by x over 5 minus 7 over 10. So the hard part would be getting a common denominator in this, because I want to get a common denominator between all of these little denominators, a 6, a 3, a 5, and a 10. So I'm looking for a number that 6, 3, 5, and 10 all go into. Okay, so let's see, 10's the bigger of the number, so let's just try multiples of 10 and see if any of these go in there. 10, well 6 doesn't go into 10, so 10 after 10, so I'm just listing multiples of 10. So after 10 we got 20, well 5 goes into 20 but 6 doesn't. What about 30? 5 goes into 30, 6 goes into 30, and 3 goes into 30. So it looks like my common denominator there would be 30. So I'm now going to multiply this numerator by 30 and this denominator by 30. So now I'm going to distribute it in. So I'd have x over 6 times 30 minus x over 3 times 30. So I'm just distributing these into both of those. So there's my whole numerator all over. Now do the same thing here. X over 5 times 30 minus 7 over 10 times 30. There's my whole denominator. So now let's simplify this fraction here. So this, if I multiply this, I would have 30x over 6 minus 30x over 3 all over 30x over 5 minus, 210 over 10? All right, so and when writing this on your paper, would take 4 lines of lined paper, because I need a line for each of these pieces. 1, 2, 3, 4. So make sure you give yourself enough room here. Well, now I can take this 30x and divide it by 6, because 30 divided by 6 is just 5. So this simplifies to 5x minus 30x divided by 3 simplifies to 10x. 30x over 5, this is 6x. 210 divided by 10 is 21. Okay, so now simplify. 5x minus 10x, well, I can put those together. That's negative 5x all over 6x minus 21. Now let's see, simplify. I could take a 3 out of this down here. So if I take a 3 out, I'd have 2x minus 7. But that's not going to simplify with the negative 5x. So I'm thinking this will be all we're left with there. Okay, the negative 5x over 6x minus 21. Okay. Okay. All right, so then we have one more. Okay. So again, here we have, okay, here's numerator, here's denominator. So now I need a common denominator between all these little denominators, x minus 2, and x. So the one they have in common is an x minus 2. So x minus 2 would be part of my common denominator. That would take care of this guy and this factor. But then I also need one to take care of the x, so I'm going to have to multiply also by an x. So I need to take this whole thing and distribute it into there. So I'm just going to write it as 6 all over x minus 2 times x minus 2 times x. All over. I have to do the same thing down here. Distribute this into, there's a plus sign here, so I have to distribute this into both of these, this one and that one. So we'll have 1 over x minus 2 times x minus 2 times x plus 3 over x from this guy times x minus 2 times x. Okay, now here we can simplify this numerator. These x minus 2's will divide out. I'm left with just 6x. All over. Here these x minus 2's will cancel out. I'm left with 1 times x. Here these x's cancel. I'm left with 3 times x minus 2. So now after doing that multiplication, like in this one, after multiplying by 30, within the next step or two, you should get rid of that complex fraction. If you don't, you didn't multiply by the right thing, or you multiplied wrong. Okay, so then now the only thing I need to do is distribute this 3 in. Six x, 3x plus x, 4x. Okay, and I think this simplifies because I can take a 2 out of my denominator. I'd have a, oh, missed the 2. I'd have a 2x minus 3. And I can take a 2 out of my numerator, I'd have a 3x. The 2's divide out, so we're left with 3x all over 2x minus 3. Okay. All right, there's one last little thing we need to talk about in these problems, and the textbook will always show this little extra thing in our answer, is if we look up at our original problem for this, let's say this one, for example. Okay, if we look at this original problem, we know that you can't divide by 0. Okay, so it's not, you can't divide by 0. We know that. You can't divide by 0. So in this original problem here, x couldn't be 2. Because if it was 2, I'd have 2 minus 2 would give me 0. So I look at my denominators of this original problem, and I can see here that x can't be 2, so I could say x can't be 2, but also x couldn't be 0. Back in this original problem, x couldn't be 2 and x couldn't be 0. Hey, but through the simplification process, hey, we get to here, well, in this one, x could be 2. I can put a 2 in there. I can put a 2 in for that. I'd get 3 times 2 divided by 2 times 2 minus 3. If I put a 2 in there, I get a 6. But if I put a 2 in here, I'd get undefined. So for me to say that this and this are equal everywhere, hey, we would need to take this guy and put it onto this answer, meaning we would need to say, okay, this and this are the exact same. You see that we are implying equals because every step we do keeps this thing equivalent. Hey, but for these two things to be equal everywhere, this guy can't be defined at 2 and it can't be defined at 0 because this one is not defined at those 2 spots. Okay, so the textbook will add this little tidbit. I want you to be aware of that. Hey, your practice needs to have those, so make sure, and your skill check needs to have those. So if you're not exactly sure, this just goes back to that idea of domain. We need to list the domain of our original function, so that way we can have that domain here on our new function. Okay, and it's obvious, it's not obvious, but we can tell here that like in this one, sure, x couldn't be, what could x not be? Well, whatever makes 2x minus 3 equal to 0. So we'd add the 3, 2x equals 3, divided by 2. X couldn't be 3 halves. Okay. Well, x can't be 3 halves in this one, but x can't be 3 halves in this one either. And since it's already in there, you don't need to list it, because it's already, anybody could figure it out because it's right there. But if all you're given is this, they wouldn't be able to figure these out. So that's why these ones have to be listed and this one does not. Okay, so hopefully that helps you out a little bit. If you need help with that domain idea, please come see me. I can do a few more examples with you. We can talk about it a little bit more. Okay, for your practice, you have some practice from your textbook, but you also have some con practice I've assigned to you, so go to your con assignments. You should have one assigned. If not, please come see me, where you need to do 3 or 4, I believe 4 of them in con, okay, which means you're going to need paper and pencil because these cannot be done in your head. Okay, so you have not only textbook, but con practice to do before your skill check. All right.